let's use the definition of continuity to determine whether this piecewise function is continuous or not continuous at 1. First step, we want to check if f of 1 exists. So looking at these inequalities, since x equals positive 1, that satisfies this top inequality, meaning we're going to plug 1 into the top function. So you end up getting 0, and that means that f of 1 is defined. For step 2, you want to identify whether or not the limit as x approaches 1 of f exists. So since it's a piecewise function, we're going to check the limit from the left and the right. So I set it up. We have the limit as x approaches 1 from the left of f of x. And next we have the limit as x approaches 1 from the right of f of x. Starting over here, it says the limit as x approaches 1 from the left. So looking at these inequalities, that would be this top one. X less than or equal to 1 describes approaching the values of 1 from the left. So that means we're going to plug in the quadratic right here. And if I were to distribute this out, you'd get a polynomial, and according to the direct substitution property, we can plug the 1 right in. So you end up getting 0. Over here it says the limit as x approaches 1 from the right, and again, looking at these inequalities, that would be x greater than 1. So we're going to substitute in ln of x for f of x. And to identify the limit as x approaches 1 from the right of ln of x, let's look at the graph for ln of x. It looks like this. It hits the x-axis at 1. So you can see as you're approaching 1 from the right, the height of the graph is approaching a height of 0. So this limit equals 0. Since the left-hand limit equals 0, which also equals the right-hand limit, we know that this limit exists, but I'm going to write that out. So I just wrote, since the limit as x approaches 1 from the left of f equals 0, which also equals the limit as x approaches 1 from the right of f, therefore we know that the limit as x approaches 1 of f also equals 0, therefore it exists. And then for part 3, you just want to verify that the answer you got in part 1 equals the answer that you got for part 2. So I just wrote that out. I have f of 1 equals 0, which also equals the limit as x goes to 1 of f of x. And therefore, by the definition of continuity, f is continuous at x equals 1. All right, guys, thanks for watching.